Hello, my name is Antonio Gutierrez. I am in Intro to Cell Biology Lab, and I have right here my chemistry concept map. Now, for the remainder of the video, I will be behind the camera in order to explain better and in order for me to get a better and clearer view of everything. So I would just like to also state that at the end of the video I will insert a picture of the entire map. So if you would like to pause it and view it, that'd be more than fine and you'd be more than able to. Alright, let's begin. Okay, so this is my chemistry concept map. I'm going to begin with chemistry right here in the corner, and I'm going to start from the first link, which says chemistry can be broken down into two types, and we obviously know that's inorganic and organic chemistry. And now organic chemistry, which contains functional groups, and I have the examples of all the functional groups we were given in our list of terms. They're all right there. Hydrol, and it ends with phosphate right over there. Okay, now I'm going to go off the second branch of chemistry right here, which basically tells us the father of modern atomic theory, who is John Dalton. And John Dalton, he redefines atoms. That made him the father of modern atomic theory because he was basically, he gave a new proposal as to what an atom was. Now in an atom, it contains protons, neutrons, and electrons. I'm going to come back to the electrons, but I'm first going to start with the protons and neutrons. Protons and neutrons are found in the nucleus of the atom, and if this nucleus ever becomes unstable, we have a radioactive isotope. And when the half-life of the atom decays in the radioactive isotope, we have what is known a half-life. Okay. And then electrons are found in electron shells. I probably should have gotten to that earlier, but this is just the navigation of the electrons. They're found in the electron shells. They have different energy levels, and then the last level contains valence electrons. Now these valence electrons obviously help bond and everything with whatever atom the electrons are in, just because they're in the last shell. Okay. Okay, so I am going to, there's one more thread here from electrons, and it goes right up, it passes the protons and neutrons thread, and it says that electrons that are transferred between two species, they form redox reactions. Now redox reactions are reactions that contain oxidizing agents and reducing agents, and the oxidizing agents are the electron acceptors, and the reducing agents are the electron donors, as you can see right there. Okay, so another thread from atoms, I'm basically gonna go to the thread that says atoms make up elements. We all know that, and elements contain an atomic number and an atomic weight. Okay, and that's just how we can differentiate between different elements. So the examples of the elements I've given to you right there. This is also some of the elements that have been on our list of terms. Are oxygen all the way through calcium. And as I have a link there that says oxygen and hydrogen, they form water, which is we know as H2O. Okay? So before I get into water, I'm just going to come right back into the atoms right there to finish up this other link. And I'd like to say that atoms join to make molecules. And just like I said, the oxygen hydrogen atoms, they make the molecule H2O. So they just combine and do that. So I'm going to go ahead and get back to water. I'm going to go off the first thread, which says water is a polar covalent bond. We know that because the oxygen has the higher dipole moment, and it pulls the other little hydrogen bonds, the H2, up in towards the oxygen's direction. Okay, the second thread on water, we have water added with more water, and we know that it's water molecules I'm talking about, makes hydrogen bonds. And eventually all these hydrogen bonds lead to a hydrogen bond network of water, which is basically all the available, the O's and the H's are connecting, and that's just how we make water, right? The third thread right here, we say water behaves like an acid and a base. Now, that's basically the best example is the dissociation of water. We know that it dissociates into H plus or OH minus. So that's just, it depends, as I have in the other thread right there. When it is dissociated, it just depends on the pH, and we know that pH is from 1 to 14, with 1 being the most acidic and 14 being the most basic. Okay, we're going to go off the thread from the base. It says that bases contain hydronium ions, and that's just that is the H3O plus ions. No, I'm sorry. Yes, they are. No, I'm so sorry. It is the yeah, it is actually. I'm sorry about that confusion. A little mess up. But we're going to go right here to the acid, which contains hydronium ions, or hydrogen ions, I'm sorry, which are the H plus ions, okay? All right, and we're going to go to the next thread from water, which basically says water can have hydrophobic interactions, and that's through adhesion. Yes, so the next thread is water is attracted to other water molecules through cohesion, and that's just when two molecules of the same species are attracted to one another. That's cohesion right there. Okay, so I'm going to come down now that we solve water. I'm just going to come down right here to say salt forms from when acids and base react. Okay, so that's just that's the acid-base reactions, and salt is very soluble in water because of the ions in the salt, and the ions, the positive and negative charges that react with water very well. Okay, I'm going to go now to the molecules side of my chart, and I'm going to just start with the thread that says molecules with different arrangement of atoms and properties are known as isomers, and that's just a basic definition. Now I'm going to go off this next thread right here, which says molecules which are held together by nonpolar covalent bonds, double covalent bonds, triple covalent bond, and ionic bonds. That's just all the bonds that can hold together molecules and other molecules. And the thread from all the bonds says that all these bonds, the strength and the tendency of other atoms to bond is determined by electronegativity. And as we know, electronegativity with elements increases as you go up the periodic table and to the right. Now, I just want to say real quick that ionic bonds are made up of cations and anions. Cations being the positive ions and anions being the negative ions. Okay, and the last thread right here, which is molecules, we're going to follow it. It's that little green one right there, the sliver. And they are discussed by their mole or molar weight, molecular weights. It's just another way to determine which molecules are which. Now for moles, we know that the moles of solute in solution per liter of solvent is molarity, and that's just moles over liter right there. And we know how to get from like atoms to molecules, we just use Avogadro's number, which is 6.022 times 10 to the 23rd power, and that's just another constant. And there you have it. That is my chemistry concept map explained.